Beyond Tech Tide. In search of the tech world.
Imagine standing near a black hole. As you inch closer to its event horizon, something extraordinary happens. Time slows down. What would feel like minutes to you could be years for someone far away. This isn't science fiction, it's the fascinating reality of how gravity and time behave in space. Welcome to Beyond Tech Tide, where we unravel the mysteries of the cosmos. Join us on this thrilling adventure as we dive into the mind-bending world of gravity and time dilation. Today, we'll explore the incredible relationship between gravity and time, two of the most fascinating concepts in astrophysics. We're about to reveal how the very fabric of space-time is stretched and distorted by gravity, affecting not just how we move through space but how we experience time itself. Did you know that if you were to travel near a black hole, time would behave differently? In fact, the stronger the gravitational field, the slower time moves. To someone standing far away from a black hole, it might seem like you're frozen in time, while you're still experiencing the passage of time as usual. This strange phenomenon is known as time dilation, and it's a crucial part of understanding how gravity works in space. Gravity is the force that pulls objects towards each other, and it's responsible for everything we see in the universe. From the motion of the planets to the formation of stars and galaxies, gravity governs it all. But what happens when gravity gets stronger? What if you were near a supermassive object like a black hole or a neutron star? This is where the fabric of space and time itself becomes warped, as described by Albert Einstein's theory of general relativity. General relativity tells us that gravity isn't just a force, it's the warping of spacetime itself. Think of spacetime as a fabric, and when a massive object, like a planet or a star, sits on it, it creates a deep depression. This depression causes other objects to move towards it, much like how a marble will roll towards a bowling ball on a stretched-out rubber sheet. While the concept of gravity is relatively easy to understand, grasping how it affects time is more challenging. When you look at space, you realize that the universe is filled with objects of varying masses, from tiny asteroids to massive black holes. And the stronger the gravity, the more space-time is warped. This leads us to one of the most puzzling and mind-boggling consequences of gravity, time dilation. Imagine this: if you were orbiting near a black hole, your clock would tick slower compared to someone who was far away. This is because the immense gravity near the black hole distorts the flow of time. To someone observing from a distance, you would appear to be frozen in time. But for you, time continues at its normal pace. It's almost as if you're in a different time zone, but this time zone is shaped by the gravitational field you're in. Time dilation isn't just a thought experiment, it's something we can observe and measure. One of the ways scientists study time dilation is through satellites. For example, NASA's GPS satellites orbit Earth at high altitudes where gravity is slightly weaker than on the surface. If time dilation didn't exist, the clocks on these satellites would be out of sync with those on Earth, causing errors in positioning data. In fact, scientists have to account for time dilation in their calculations to ensure the GPS system works accurately. The difference in time between the satellites and Earth's surface is small but measurable, just enough to make the GPS system useful to us every day. Now, let's take this a step further. Imagine what would happen if you could get close to the event horizon of a black hole. This is the point of no return, where not even light can escape. As you approach it, time for you would slow down more and more, while for someone far away, it would appear as though you were freezing in place. The closer you get, the more time dilates until, at the event horizon, time essentially stops. But don't be fooled, time doesn't stop entirely for you. From your perspective, time still flows. It's only from the perspective of someone far away that it appears to stop. This is one of the most mind-blowing effects of general relativity. Time, the most constant thing we know, behaves in ways that defy our everyday understanding. To summarize, gravity and time are intimately connected in the universe, and through Einstein's theory of general relativity, we've come to understand how gravity warps spacetime and causes time to behave in ways that seem almost magical. From black holes to GPS satellites, time dilation is a real, observable phenomenon that challenges our basic perceptions of the universe. It's one of the many cosmic wonders that makes space exploration so exciting. In the quest for a theory of everything, a unified explanation of how the universe works, understanding the relationship between gravity and time is a crucial step. It helps us understand not just the cosmos around us, but the very fabric of reality itself. If you found the fun side of astrophysics as mind-blowing as we did, we'd love to hear your thoughts. What do you find most fascinating about time dilation and gravity? Drop your comments below, and make sure to subscribe to Beyond Tech Tide for more space and physics content. We've got more cosmic wonders waiting for you.